Okay, I think someone is watching the same video. It's not me. Okay. Okay, guys. So doing that is also like a cost-effective process that we have to take a proper precautions for that. So this is one of the best example for that. So this we will firstly start in the next week. So I want you to practice on that. But even this also you can start practicing it because you know how to build the soil layers, the clay and the sand. And in the same material, the complete material information is given. And you can go for this 1 meter, 19 meter, 10 meters. That means 20 meters of a clay and 10 meters, sorry, another 30 meters of a sand you have. They're going with as a diaphragm walls in between.
Your
How to model?
screen, Mr. Sai,
Yeah.
screen is not showing.
Oh, I'm sorry. Now?
Yes,
Yes,
now
yes, sharing. Yeah, yeah.
Oh, okay. Thank you. Thank you, guys. I'm sorry for this. Okay. So this is 20 meters of a clay and 30 meters of a sand, and they were building up the diaphragm walls and the struts and live load also. Because to excavate this, we have to maintain some machinery we have to set up over there, and then we have to excavate this one. So now you guys tell me that this particular model comes under a plane strain or like an axisymmetric model.
access symmetry.
So
Plain style only.
okay, so two have voted for plane strain and one have voted for axis symmetric. So why it is chosen as an axis symmetric, Jairam?
There's a symmetric loading on both sides. The loading is activating. Identical loadings are there, 5 kilometers, and the distance and all the parameters are same, right? J and time.
But they were never says that excavation process is in circular process. But in the
So
geometry,
in
they never
where,
mentioned this
yeah,
excavation is a circular one, right?
Yes, sir.
Okay, so the option that we have to choose it as a plane strain
Okay.
mode, plane strain model. But
Okay.
actually, again, this is geometrical symmetry. You're 100% accurate. If they have mentioned this particular distance, this 30 meters, whatever they have mentioned, if they have mentioned it as a 30 meter diameter, then we can go ahead with like
Okay.
as a circular footing. Again,
Axis.
the meaning of it is again this particular load, the machinery I cannot able to apply for the entire circle. So these are the two constraints that which are not allowing me to choose this as a axis symmetric problem. This problem is comes under a plane strain problem at any condition.
Okay.
So you got me like, see, when I just go for this particular problem, if I choose this as a axisymmetric, okay, initial soil layers, I can model this as a circular in shape. So this is not exact circle, but assume this as a circle. And this excavation part is also to be a circle, which is not given in our problem. That is one wrong when we are going this. And this
Okay.
loading whatever I have considered over here, again, this loading will keep repeating along with the circle. Again, this is also completely wrong because they have given only a single place loading from the understanding. And clearly they are mentioning the geometry of a model situations of a submerged excavations. And they never mentioned this as a diameter. So this is to be a plane strain model. And the one thing, all the circle at a time loading is not possible. There is no machine like that that which can able to do such kind of operations. So it's which is not possible. That's also unrealistic one. So by considering this two, I am considering this is a plane strain. So yes, this is a plane strain model that we are considering. Okay. And then now we have to know how to build the soil layers. We have know how to build a clay and the groundwater head level that you can assume some head level like at minus one or something because our major criteria is to submerge everything. Okay, let's consider it's a -1 where uh, above 1 meter level that vehicle passes as a something equipment that we can consider that. And the new things that we have to learn is how to build a diaphragm wall, how to build a strut. Can I able to implement this in a symmetry nature, not a axis symmetry, geometrical symmetry? That means only half I can able to do and the half I can able to reflect. That kind of an assumptions is possible in this or not. So those kind of an assumptions that we have to make, and then we have to finalize that one. Okay. Yes, geometrical symmetry is always possible. We can do only half of the model because both the sides is of a same. So I can assume that the other side is also having the same amount of stresses and strains values because it's a geometrical symmetry in nature. Okay. So that's pretty much clear for us. And then he has given this, it's a pressure value. It's a pressure. It's kilonewton per meter square is nothing but your pressure value. That's load per unit meter length. Suppose here they has given it as like 5 meters is the width. That means 5 fives, 25 kilonewton per meter square for the entire area they have given it. But what we are feeding, this is in terms of kilonewton per meter square per meter. Per unit length, it is 5 kilonewton per meter square. Make sure it, guys. Never multiply that 5 into 5 and then don't give it as a 25 kilo. When you are writing it also, if you are writing it as a 25, then you have to maintain that as a 25 kilonewton per meter square. But when you are writing it as a 5 kilonewton per meter square per meter, then you have to represent 5 meters or a 5 meters of a length. Okay. So you have to remember that in feeding this particular value. Okay. This is a line load and the soil layers that we can build this. So only this particular half we can, so only this particular half we can model. Okay, only that particular half that we can able to model it. Why? Because especially I am selected as the left hand side. I am not selecting as the right hand side. There is a particular reason for modeling this kind of example, especially. So that also we have to identify that particular thing. So it's a very small reason. It's not a logical one. It's a software constraint one. It's driven by the software. When we are doing in other softwares, maybe based upon that software capabilities that we can able to model on the right hand side also. But for this example that I have to model it is on the left hand side. And now try to identify that also, why it's like that and all. Okay. So this is where the examples, and when you just go for this, they have built all those things, the plate material properties and the diaphragm material properties, everything they have given it. I'll just show you one example here. Also, they have selected it like this. They have drawn a line of the soil layers, create a line element, create a line, and then they were mentioning it as a positive interface. The moment when you just click on this positive interface, we have already seen that positive interfaces. So in this side, it will come. Now see this one, this side part only they have selected it. That is where this side part they have selected it and they are modeling this one. So the important criteria to model only this side part is to model this element. That is nothing but your fixed end anchor. Fixed end anchors can be always travel from left to right only. It will never travel from right to left. That's a constraint. Because of that, it has been generated it like this. Okay. So shall we start this, guys, and we can continue today? No issues for you? Or if you mess up with many things, then slowly we can start in the next week also. No issues. As you suggested that we can follow it.
Whatever it may be. Okay.
No, I'm pretty much comfortable with anything. No issues.
Yeah, continue, no problem.
Yeah. Okay. Uh, just take a 2 minutes break. I'll sip some water and then I'll come back. Okay. Yeah. Okay. Thank you, guys. So now, actually, so we will go back to the statement now that we will solve it very easily, as because we know all the things. We'll just keep this because we can model this soil, clay and sand, and we can just go. I'll just save this, go to a new project. In the new project, I can just mention it as submerged excavation model, plane strain, 15 noded. I have to choose my X max and Y max or the Y minimum. Y max, I'm keeping it at 0. And the Y minimum is like 30 meters and 20 meters. So totally is 50 meters. And X max, I'm just modeling only the half of it, right? I'm just modeling only the half of it. That is 15. 15 plus 2 is 15 plus 2 is 17. 17 plus 5 is 22. And 22 plus 43 is, you guys can hear me, right?
Yeah, 65.
Oh, okay, fine. Okay, okay. I just want, because no one is answering it. I thought like whether you lost your voice. Okay. Okay. So we were just doing that, guys, like to the 65 can model it. Okay. So I just go back and I will consider this X max or X minimum, that which we want. I want to go on the negative side. So that is on 65. So X max is of 0 that I can consider. Now because I'm completely traveling on the negative side also. Okay. But even if you just want it, I can shift this particular position like maybe 0 comma 0 I will consider over here. Even in this direction also I can go. So either wish that you just want to go, we can consider that one. I want to go like X minimum as 0, and this because keeping a negative values is quite difficult. So I'll just maintain like this. That means when I'm just maintaining like this, where the origin point is, somewhere else over here, I'm considering the origin point. I'm not here considering over here, okay? Okay, and with this considerations, I can go build soil layers, click on this borehole, add two different soil layers. One is from 0 and minus 20, and the other one is from minus 20 to minus 50. That is steadily. And then I have to create a two different soil layers. This one, I can name this as a can just mention upper sand or a clay. And the material model for the clay, they have given it as a hardening soil material model. So I have to choose this as a hardening soil. And then they have given your saturated weights as in 16 and 18. So I just want to feed this as a 16 and 18. And then I want to go for a parameters tab. So parameters tab, like I want to feed E50 value. E50 is 4. That means E audiometer is 3 times of it. 4 3s are 12. Okay. So automatically it will calculate 4E3. If you just keep, then automatically it calculates the 3 times of it. And the next one is odiometer reference values, that is tangent stiffness, that is stiffness in tangential directions that we want to define it. That is 3. What is that? 3.3 E3. Okay, so it's always odiometer results, odiometer Young's modulus results, that is 100% odiometer loading, will always having a lesser stiffer than for 50-meter loading conditions. That's where you can define that. If you don't have this E odiometer, you have only a E50 values. Yes, 50, you can feed this. Multiplied with 3 times gives you the full, that which calculates with the software automatically. And this one, you're just little lower than that. Okay. Okay, after that, you have to go for your cohesion, friction angle, and dilatancy angle. So here they have mentioned it as an undrained A. I'm sorry, like, guys, this is undrained A behavior. This is an undrained A behavior. So what we are feeding is both effective properties, and then the pore pressures will be calculated above the pneumatic levels also. Above the pneumatic pressures also, it will calculate it. Okay. Now, after feeding that, like cohesion as 1, cohesion as 1, friction angle as 25, dilatancy angle as 0. And then again, they are defining it as like a Poisson's ratio, which is 0.15. Okay, which is 0.15, which is some of our advanced material properties, which is not mandatory to feed this, but whenever you have these particular values also, you can able to feed this. KV value for normal consolidations and all. This is 1 minus sine phi values. So that if you just want to feed that also, you can able to feed those particular values. KV values for normal consolidations that will calculated by the software automatically. Okay. And here he was defining about this groundwater also, because we are handling water is also a little important in this. That's the submerged conditions, and the water which is in the soil which is inside the water, that we were disturbing it. So we have to define this groundwater conditions carefully. So to define this groundwater conditions, Plexus people always prefer that. They always try to prefer this USDA model. USDA model is nothing but United States of Department of Agriculture. So they have defined certain parameters for this. Out of this, the famous model is like only the Van Gishen model. And the in the Van Gishen model, you have like soil microns that you have to define it. Less than 2 microns, what is the percentage of the sand? Less than 2 to 50 microns, what is the size of percentage of the sand? And this like this, and the soil total volume that you have to divide it into your percentages that you have to feed those particular values out there. Okay. So here 90% is about like 50 microns to 2 mm, and 2 microns to 50 microns is 4%, and less than 2 micron is only the 4% we have. And permeability, you have to define this. Whenever you are doing any kind of exercises related with the pore pressures, you have to maintain this permeability values also. 1 e power minus 3, the permeability in x directions is velocity, the water can flow in that particular, it's a meter per second or meter per day, meter per time, or distance per time is nothing but your velocity. So here you are defining it as a meters per day. So the velocity in the x directions, the permeability velocity in the x directions is an x direction is 1 e power minus 3, and as well as in the y direction is also having the same value, 1 e power minus 3. Okay. And then now these are the two parameters that you have to feed it. And then they are going for this, the new module that's called as an interfaces that you can see. This called as an interfaces. Thermal I'm not going because I'm not involving any kind of a thermal activity in this problem. I'm involving only the interfaces. Okay. Interfaces, why they want to do is, in this example that previously when you just go here, we have drawn a line. We have drawn a line, and this particular line we are calling this as a diaphragm wall. And this particular line we were calling this as a diaphragm wall. And I have to tell to the software that I'm inserting a structural element inside the soil layers where it has to maintain the contact between your clay and as well as the sand. And there are two different things. I cannot define the interfaces to this directly because it's an interactions of both the clay and as well as the sand. So any structural element interactions with the clay is having a different properties. Any structural elements interactions with sand is having a different properties. So those properties are nothing but they have defined over here for us. So they have defined here. So this is after the groundwater sets everything, interfaces is this is what actually. So here it is, our interfaces. That means the friction between the clay and the structural element is 0.5, and the friction between your sand and structural element is 0.67. They have found. So go to the interfaces, make it as a standard one, and goes as a rigid. And you have to choose this like as a manual one to feed this particular values. Once if it is a rigid, by default, it's going to take it as a 1. So it's a manual. So now you have to feed this particular value. That value is nothing but 0.5 is the value that you have to define it. That means what's happening is whenever any soil clay particle is coming in contact with this particular structural element, the friction between these two is defining in terms of an interfaces, and that particular friction is nothing but a 0.5. If it's a frictionless, then there is no resistance to the force opposition resistance. If the friction is like 0.5, that which is 50% of the resistance will come. And if the friction is like 0.6, 60% of the resistance will come. If it's a friction is of a 1, then it's 100% resistance, which is not possible actually. Okay. So here they have defined it as a friction value. And then as water handling is very important, which is a kind of some consolidation parameters also we have to fit. So for that, they are giving this over consolidation values and pre-overburden pressures on the soil also. Okay. So go to this initial for that. Initial phase, we are calculating the KO process, right? KO procedure is automatic. I just mentioned it. That is 1 minus sin phi, it will calculate. And if it's over consolidation values for the soil, parameters are available, then you have to feed that one. Here they have mentioned it as 1 is over consolidation and POP as 5. For certain cases, consolidations are like 40, 50 also you have to feed. That's specially driven by your lab guys. Whenever that value demands your site, then you have to feed this particular values like, okay. So I'm just giving this in detail that we are going to discuss it in our consolidation analysis for that. Okay. This is an upper sand. Similarly, I just want to go this lower sand. That is sand again. And that particular model, they have selected as drained and it's a hardening soil model. So this is a hardening soil model and this is completely a drain. And now I have to feed my saturated and unsaturated weights. So this is 17 and 20. And both they have fed it as the same values, but which is realistic a little less possibilities, but as it is possible because this is a second layer which is having the same amount of a stiffness in both the directions. Maybe it's a second layer. So we can consider this as a 40 E3 and then it's also a 40 E3. Automatically it's calculating. Sorry, it's 40 E3. 40 E3. Okay, and the power value they have given it as 0.5. And sand 0 they have given it as like if you just see this cohesion as 0. And then again they have given this as like 32 and 2. Now they went with the 32 and as well as 2. Okay. Now the doubt comes here. Cohesion value, they have fed it as 0, but it's always recommended to go it as like at least a unit value. That is what assumption that we have made it in our previous sessions also. A cohesion value, we have to made it as like approximately at least like 1. We have to consider that. But here they were mentioning it as a 0. Whenever your part of a cohesion comes onto your second layers of a soil or the third layers of a soil, which there is no excavation is also not happening it. Extra only the foot diaphragm walls are coming, which is also a support addition only. It is not a stiffness removal, it's a stiffness addition. So in that particular cases, cohesion won't plays much role. Cohesion plays much role only in the soil collapse envelope development where this particular soil needs it, because all the operations that we were doing on the top layer on the clay, we are not doing all the operations on the sand. So for the clay, cohesion feeding is very important. So for the clay, they have mentioned it as a 1, and for the sand, they have mentioned it as a 0, which this particular statements, these kind of informations will not explained in your tutorial manuals. That's why, but they just mentioned that values as clay as of a 1 and sand as a 0, that you have to understand. But actually, they have mentioned it as a dilatancy angle is also 2 for this particular sand. Why they have mentioned the 2 for this particular sand is, whenever you are trying to do this excavation process, whenever you are trying to do this excavations process, and when you are trying to remove this particular parts, your diaphragm wall, whatever it is there, it initial position is this one, and it always tries to bend in this. Okay, so whenever the position changing, it is coming over here. So which is like this, which is like this particular thing, we want to capture it at the tips, which is not at all in fixed. So, and this particular tips are coming inside the soil layer, inside the sand layer. So that's why they are feeding this particular value as a 2 for this, to identify your shear forces also, which is beyond the yield, it may go over there. So to identify that, they have identified this particular interactions. So they have fed this as a 2 value over there. So it's where like you can go, it's a 2. And now I can go up just like any velocities that I have mentioned. It's Poisson's ratio is 0.2 again. These are all like alternative stiffness values that will be calculated by the software automatically. 0.470 is 0.4701. Okay. And the groundwater is standard and coarse. The groundwater is standard and as well as a coarse. And these are the values that we want to feed. That is user defaults is none. And this is 1 and 1. 1 and 1. Okay. So, but preferably if you have these agriculture values, United States Department of Agriculture values, try to prefer that. This gives you a more accurate and more robust algorithms, because this uses a Van Gogh. But this is a second layer. Again, I'm not preferring that. So I can just go simply, okay. You are. See this one, it's a 40E3 and 40E3. It's asking you that like please like make it as like higher value. So I can just make this value as, okay, I can just make this particular value as 39E3. Okay. 2E50. So this is 3 times of it. 4 to is 12. This is 12E3. You have to feed this one. Okay. Oh my God. 43 is 12. Sorry guys. Okay, that is 4 to is 12. That is I just mentioned it as 12. It's a 40, right? 120 we have to feed. Okay, this is what it has been created now. So we have this, and we have to define this in the borehole. We have not defined the head. So head, I just want to define it as -1 meters. The water level here is like up to -1 meter of water level. So now going on to this structures module. So now in the structures module, I can see this one at a 15 meters distance. I have for a depth of around that is 20 meters, another depth of 10. For the depth of around 30 meters, I have a line like diaphragm wall. So which is a if you are confused about of selections of this, roughly go this. This is 65. 65 minus 15 is 50. I have to come. So select this 50, and then I have to go up to like 30. This is where the line I have just created it. Now in this line, right click on this, create, and you can just create a positive interface. Positive interface is this side it is coming it, whereas this side it is not coming it. Important thing you have to know this, guys, why I'm creating only this side and why I'm not concentrating on that side. You can do it on the other side also. It's nothing wrong. You just maintain this, create negative interface also. It's nothing wrong on creating on the other side also, but I'm pretty much sure I'm creating on the right side because this part has to be an excavated. This part has to be an excavated, which is more in contact rupture will happen it. So that's why I want to define it on the positive side is must and should, but you can create it on the negative side also. Okay. So this is where the interfaces we have created it. So based upon the interfaces module that which we fed for both the soils, that based on that, that is going to be. Okay, so I think interface for the soil that we have to feed it. We forgot that one. So go up to the materials, Control M for the sand, edit, interfaces. I want to make this not rigid, it's a manual, it's a 0.65 value. And for the initial consolidation values also have it. That's for 1 and 0. Okay, that's there. Okay. And now I want to convert this as a plate element. This, what are the line I just selected, right click on this, create, and then I just want to make it as a plate element. By creating this as a plate element, that will convert into your diaphragm wall. Now for that diaphragm wall only, we have to feed a material properties. So to define the diaphragm wall, these are the EA values and EI values we can use. And to do that EA and EI values, I want to make this as a plate element. So now I just made this as a plate element, expand this. I want to create material. So I just want to name it as a from wall. This is a wall. So EA is 7.5 E6 and 10 E6. Sorry. This is 10 E6 that we are feeding up. Okay, that's perfect. So we have applied a plate element material. So that wall element also we have applied it. Now I just want to start up my excavation process. So excavation process, I understood from the problem that initially I have one strut element over here. To model that particular strut, I have to excavate up to a depth of around 1 meter first. So for that, what I will do, I'll just create a line, up to 1 meter depth. I'm just creating a line. Up to 1 meter depth, I'm just creating a line. So in between, try to save this particular problem. 1 meter line, I'm creating it. And now, if you are like very new to this particular software, right? So I recommend you like first line is there, go to the mesh. Now select this line, make this as a 0.25 as a coarseness factors, so it turns into a green. Try to generate a mesh. Okay, after generating mesh, go to the flow conditions to check the water level, go to the stage construction, add a new phase, and this phase, I name this as a, I'll name this as a excavation one. Excavation one, as it is by default, I'm leaving. And in this phase, this particular part that which would I would like to excavate it, right click on this and I'm selecting deactivate it. Right click on this and I'm making it as a deactivation of this. But before of this, I want to, in the initial phase itself, I want to activate this particular plate element also. I forgot that. I want to activate this particular wall. Okay, I want to activate this particular. So in the initial phase, I'm activating this wall, or else what you can do is you can delete this. Whatever it is there, that selection is there, right? Plate, you can deactivate it. Add this phase, wall construction, wall constructions you can do, and activate this plate and add another phase, and then you can rename this as excavation one. And then I'm doing this excavation process. I just did this excavation process. Now try to calculate up to this. Any, as you are very new to this software, after spending so much of a time, then I found that there is something wrong in my initial model itself. You should never realize that one. So I recommend you to model this in this particular way so you can able to understand. Okay, now till this, it's working fine. It's good because the problem is solving clearly. If you want to visualize the results, you can visualize the results also. You can go there and see. But now I am coming back. Now the important one, that the model that I want to model this particular anchor. So the anchor modeling, guys, here in the line, if you just click on this black arrow or the dot, expansions of this, you can see it, right? So in the expansions of this, you can see a create a node to node anchor. This is where it helps you to create it a continuous one. This is not your fixed end anchor. This is helps you to create a continuous anchors. And you have one more icon here, that is create a structures. In create a structures, you have an option called as a fixed end anchor. You just select this particular fixed end anchor. You just select this particular fixed end anchor, and where you just want to place this, you just click over there. Just to click over there, then automatically your fixed end anchor will be placed.